Good afternoon. My name is Jason Bock. I'm a staff software engineer at Rocket Mortgage, and my fast focus topic is caching options in .NET. Here's some information about myself. I do have a YouTube channel. You don't have to like it, but please subscribe. I would appreciate it. If you want to take a look at the code that I'm going to be showing in my demo, that's the URL. So you get the slide deck from VS Live, so you can get it that way. But if you want to take a look at the code, it's there. So this link is also on the next slide. So I always see people with cameras coming up. You'll get it on the next slide as well. And you can just get the slide deck from VS Live. So just want to spend a little bit of time talking about caching. I want to spend most of the time in the demo and showing you a couple of APIs and libraries that Microsoft provides for you to make caching easier for you to implement in an application. So the goal is to make our applications faster. Does anybody want to make their applications slower? Okay, well, there's somebody nodding. Or at least I thought I saw somebody nodding. There's always a jokester in the room, right? I don't think there's anybody that is intentionally, maybe we'll qualify it that way, is intentionally making their applications slower. I know I've done it by accident. I've made many a mistake in my life as a software developer. And I would venture to guess that people in this room would also say that as well, that there are times where you've messed up and done something, and all of a sudden you release it to production, and that query that ran super fast on your machine, when it actually gets out on prod data, takes an exorbitant amount of time to run. We all want fast apps. We all want to have fast code. We want to have our users not notice how long our code is taking our applications to run. And one of the things you can do to potentially help that and make your apps faster is to use caching. Now, of course, if you know anything about caching, one of the problems about caching too is as soon as you add caching into an application, you have a memory leak. Because if you're not careful about how you do your caching, you can end up caching way too much and you're not managing all of the memory it takes to cache that data. And now you watch your memory profile of your application grow and grow and grow out of control. And now you have another problem. But we still want to do caching when it makes sense. This slide with the numbers and everything that you see, it might be a little bit hard if you're in the back of the room. But again, you can get the slide deck and take a look at this. I saw this a couple years ago, and I like it because it shows right at the top like different speeds of activities we do in software development, right? Reading data from a disk, sending a packet from California to the Netherlands and back again, doing L1 cache references. That's right on your chip. Okay, now of course, these numbers have probably changed over time as technology changes and gets better. Well, what I really like about this is that it shows just the difference it can make in terms of caching something or trying to read from it every single time. The advantage you get is speed. The disadvantage is if you don't manage it, you can grow your memory out of control. But that's why there are these libraries and these APIs in .NET to make this simpler for you and to have those strategies in place that you can define them so that your cache doesn't grow out of control. Okay? Everything's a balancing act in software. At least I think. There's sometimes where you get to a point where it's like, you have to make a decision. Do I want this faster or do I want it to consume less memory? You know, and at some point, there's just a point of no return. But if you're not doing any caching in your application, you have a great opportunity to start going, maybe I can start using some of these things that I'm about to demo and give that illusion. Well, it's not an illusion. It will actually appear to be much faster to your users, okay? So let me go through a very simple demo here. This is just getting a list of hard-coded states and picking out which state I live in, which is Minnesota, and looking at it as what happens if I have to get that list of states over and over again, and then if I use a couple of the types that are in .NET, and how does that make things easier for me? Let's get into this code here. I'm going to actually run this first because it takes a little bit of time for it to run, and then we'll come back and see what all the values mean. So the first thing is you see some entry options up here first. We'll come back to that in a second. You'll see that I'm also configuring my service collection. This is very common in .NET apps these days with dependency injection. I can configure a whole bunch of things in my service collection and then inject those into my code as needed. This is a simple program app, so I don't really have that in place, but I'll just make up I'll new up the service collection add some configuration, and then resolve values from it in my program class and then use them as needed, okay? So we'll, again, come back to these settings in a moment. They're not useful right now, but they will be, okay? I'll print out the time. You'll see that in the console app, and just to get a feel for what's actually happening when I'm retrieving stuff. I'm going to get a list of states, and you'll see how that's done in just a moment. And then I'll also print out what index Minnesota is in that eventual list that we get back. Okay, a little bit hard to see, but it's a list of strings that we're getting back. Okay, and that could be anything. That could be any type of data that you have in your application, no matter what it is. In this, it's just a list of strings. So I'm going to get it. I'm going to call it again, get that index, and then I'm going to start using a local cache where I don't actually have to go back and use that again. So in this case, I'm going to use a local cache of just that list that I already retrieved. Then I'm going to go into something called a memory cache. And before I get into that, let's go back into the console output so you can see what this is actually doing. We'll make that a little bit bigger. You see here I'm getting the list of states. I retrieve it, and it's taking a second to get 50 string entries. So I get that list of states after a second, and Minnesota's at 22. So if I get it again, obviously it's going to take another second to get this data. This is a prime candidate of data that you want to cache because the number of states in the United States hasn't changed since, what, 1950? You know, that's a very, very static piece of information. In fact, if you think of code that you've written in C#, if you ever declare something as a const, like a const string, and you have another assembly referencing that code in that assembly, it will actually inline that value into the calling assembly. Because a const is considered to never change, ever. That's why pi is 3.1415, whatever, in .NET, and you know that value never, ever changes. So you can inline that. So if you ever declare something as const, keep that in mind, because if you change it, calling code has to actually recompile. It won't pick up the change. Okay? So state data is very static, and that would be something I would want to cache. The way I'm doing it right now, just to illustrate like a slow running query, is if I go to the definition, I'm just artificially adding in a delay of 1 second. Okay? So that's where that 1 second delay was coming from. And you might have a query that just takes that long. If you do, and the query doesn't change, you'd want to cache this. That's why in the third example, when I say using local cache, that's just using the list I got the second time, and trying to find that index is very, very quick at that point. But we don't want to just be managing lists all over the place. I don't want to have read-only fields in all my classes or all my objects and having to remember to get that back every single time. And then what happens if I would start caching more and more data? How do I make sure, again, I'm not increasing that memory pressure too much in my app? That's where you can use something called a memory cache. So in here, with the service collection, you can see I'm calling add memory cache. And this is something that is in .NET itself. It is in memory cache, so it only lives for the lifetime of this application. And if you think if I'm hosting my applications in something like Kubernetes and I have multiple instances of my application running, each one in this case would have their own memory cache. And these are not distributed, so they're only on those machines, okay? So just keep that in mind, becomes a little bit more important when I start talking about hybrid caches. So memory cache is in that application. When I start to retrieve data from that cache, here with get or create a sync, there's a couple of things I do in here. So if I zoom in on this, the first thing is a key. And so I'm just using a local constant to differentiate this data from other data that exists within the cache. If I don't have an entry for that data, what it will do then is call getStatesAsync. So the first time it's still got to do that second pause to retrieve the data. But once it has it, it no longer has to retrieve it again. And I can also provide entry options. So now if I go back up here, we can look at these entry options and see that these are memory cache entry options, which has a couple of values you can set to manage what is in the collection, in the cache, and what's going to get evicted depending on certain conditions. For example, I can set for this entry a entry option that says, after 5 seconds, get rid of that data, whether people have accessed it or not. Okay. There are other things you can set with this option. You can see here, and thank you GitHub Copilot for throwing that out there for no good reason. And there's other values I can put in here like absolute expiration. I can have a sliding expiration. I can also set a priority for things that should have more priority or less priority in terms of when they're going to be evicted. Their size can also matter. So if I have a set of data that I cache that's really large, I might want to then say, I don't want much more to get in here. So I want to set a size limit to what I'm caching. So you have options in terms of what the entry and the cache will do with your data. You'll also notice that there is setting here this register post eviction callback. Okay. And I give it a delegate so that if I go into what that does is it's just printing out that something has been evicted or this entry has been evicted. So now if I go back and look at what I'm retrieving from the memory cache, again, it's going to take from 2 seconds to 3 seconds on the stopwatch. That's that second pause. But then the next time when I use the memory cache, very little time. Okay. But here's the interesting thing is now I have in my code, I'm going to put in a wait time of 7 seconds, which is going to go beyond the 5-second absolute expiration time that I had configured. And then I say, well, let's go get the states again, which in this case, we go from 10 seconds to 11 seconds, because again, it got evicted. So we have to refresh that data. But notice that that eviction message comes in after I made the call to realize that that data should be evicted. So the memory cache doesn't have something that's set in there to go, oh, right at 5 seconds, I'm going to remove that data from the cache. It kind of waited until the next request came in and then said, the last time it was asked for was 7 seconds ago. I should have evicted this after 5 seconds. So now I'm going to evict the data and refresh it and get that data again. Okay. So if you ever look at like post-eviction callbacks or you look at that data and go, that doesn't make any sense. Why did it not give me that message after 5 seconds? Is because that's the way the cache works. Yep. So again, that's the memory cache. Works really well. I've used it many times in apps. It helps out a lot if you're just wanting that data to be close to the user's experience, especially like if you have combo boxes or lists of things that is always going to be the same no matter what. Those are great candidates for that kind of data. So we live in a distributed world, right? We don't live typically with an app running one instance that's servicing tens, hundreds, thousands, hundreds of thousands of users on a day-to-day basis, if not more. We have things configured in Kubernetes or in servers that they're all running this app with multiple executables running at one time. So we want to go one step farther, which is we have this notion of a distributed cache. So that cache and that data, there's an extra layer in there that is shared from all these machines. So that if one machine already had that data, I just have to get that data from that machine and have it now in my cache locally. I don't have to have all of them go to that one machine to get it. Okay, so I have this distributed notion of my cache. And there's a distributed cache API that's been in Microsoft for a while, but now you can use something called a hybrid cache. This came out with .NET 9, and if you look up here, you can see I have add hybrid cache configured in my service collection. I also put in here add distributed memory cache, just to show you that this is one app. It's not sharing anything across any other machines. And that's the nice thing about its name. It's hybrid. If you want to use it with a distributed cache in mind, you definitely can do that. You can use Reddit behind the scenes and have that in play. Or you can just use it like a memory cache would be used. And from you as the user, the API is no different. It's just what's configured underneath the scenes. And now the hybrid cache is going to look for a distributed cache and go, oh, if it's there, then I will use it. But if nothing's really configured, I'm just going to default to it being like a memory cache. So if we scroll down to see when we're using the API, it looks almost exactly the same. There's hardly a difference with the calls that you use, okay? And the end result also ends up looking the same. If I go back to my console app, you can see that again, the first time that I use it, let's scroll this down here. The first time I use it, it takes about a second, but then after that, the response is almost instantaneous. One other thing before I'm done, just to keep in mind with a hybrid cache, one of its nice features is that it has something called stampede protection. So if you have within one machine, if you have a number of these things all asking for the same data at once, what this will do is prevent all of them from making that query request. You'll only have one of them do it. But ironically, that's not across, with a distributed cache, it doesn't quite work that same way. It's only within, let me be more clear, it's only within the app that's using the hybrid cache. So if you have like multiple requests coming into it from different users through different APIs, and they all realize the data's been evicted, now they all want to call the actual invocation to get the data. But what the hybrid cache will do is prevent them from all doing it, and they'll only do it once. So you get some savings there as well, but it's not distributed. Hybrid cache is also abstract. So if you want to have a custom implementation of hybrid cache, that can easily be done. In fact, there is a open source caching package out there called Fusion Cache that's been out there for quite a while. You might have heard of it. It also works now with hybrid cache, and it has some extra features that the hybrid cache implementation in .NET doesn't have. So you could end up using that, but you'll have the same API within your application. Okay, so I am pretty much at time. Thank you for coming.